GM everyone, my name is Coxie. Today we're talking about account abstraction, which is ensure to enjoy gas-free transaction with Paymaster on zksync era. So this is my fourth assignment for Delaware University, and with me is my team member called Peter. Peter is a team member. A team member. It's among my team is one. We are all students of Delaware University. And for today, our agenda for this workshop is going to be about an introduction to zksync, understanding native account abstraction, deep dive into Paymaster, coding exercise, setting up and using Paymaster. Not only that, we're going to talk about, so now talking about zksync. So zksync leverages zk rollups to enhance Ethereum scalability, enabling thousands of transactions per second. That's what makes it scalable. zkSync's transactions are verified by cryptographic proofs, ensuring high security. That's what gives it its security layer. zkSync drastically reduce gas fee, making transaction very affordable. That's what makes it cost effective. So key features of zkSync, it has low fees, like it's significantly reduced to reduce gas costs compared to Ethereum minutes. It has very low gas fee. It's capable of processing thousands of transactions per second. It has high throughput. It's easy to migrate existing Ethereum apps to zkSync without minimal changes. So, what is talking about account abstraction? Because we all hear about account abstraction. So, compared to traditional accounts, users manage their own keys and pay gas directly to when it comes to normal accounts or using normal wallets. Users pay their gas using the native ETH token. But for account abstractions, abstracted accounts decouples transaction authorization from fee payments. It's allowing for more flexible transaction models. So zkSync, talking about zkSync's implementation to native account abstraction. So native account abstraction, which is called AA, is a protocol implementation that makes all users accounts smart contract accounts by default. This facilitates gasless transactions and enables user experience by separating transaction execution and fee payment. This also allows different tokens to be used as gas payment for transaction fees without being restricted to network native token. What this means is that, for example, now you don't really need to have the native um its token for you to be able to pay gas fees on when using zkSync as or using zkSync Paymaster. You can pay gas fee with any native token, be it USDT, whatever token you have. That's what makes this account abstraction with Paymaster very interesting and enjoyable on zkSync. So talking about the benefits of account abstraction, of native account abstraction, it's user friendly, it's flexible, it's secure, it has gasless transaction and sponsored transaction. It can sponsor transactions on its behalf with the paymaster. So introduction to the paymaster on zkSync. The first thing is that paymaster is more of like a smart contract that sponsors gas fees for transactions, enabling gasless transaction for users. Not only that, Paymaster intercepts transactions, validates them, and covers the gas fee on behalf of the users. Also, Paymaster is ideal for decentralized marketplaces, dApps with users, onboarding incentives, and any application require frictionless user experience. So if you're using Paymaster on any dApp, there's no need for the users to be able to pay a gas fee because that can be that already be covered with the specification that's specified by the developer. So talking more about different use cases, like I said earlier, it has gasless transactions, sponsored transactions, improve user experience, and consume fees structure. So talking about the paymaster, more about the paymaster. Paymaster has two inbuilt paymaster flow. There's one called the general paymaster and the approval paymaster. I'm going to show you more about the coding aspect when we start coding. But for the general paymaster, this default flow requires no preliminary actions from users. It's allowing paymasters to interpret transaction data as needed by to cover gas fee. So, but for the approval-based paymaster, this operation requires user permission. Like for example, when you want to send tokens from transfer tokens from a wallet to another wallet, you need to use this approval paymaster because you have to approve the token that will be sent by the user. So user has to approve it. That's the reason why there's a need of using the approval paymaster. But if you're not sending tokens, if you're interacting with just verbally just interacting with a normal tap, sending messages or communicating, then you use the general paymaster. So now we are going to go more into coding, the hands-on coding, start coding and know what exactly how this really looks like. So for now, let's install CLI, because you have to first of all make sure you're um using zksync CLI. You can install it using this command. I've already installed my own, and then after you're done installing it, you create a project using this command zksync CLI create project. So let me share my screen, my terminal, and create a project on that. Hold on for a bit. Let me share my terminal. Okay, first of all, let me stop sharing this one, then start sharing my terminal. Present, share screen. So, okay. So I'm sure you can see my terminal now. So if I told you earlier that there's a need to install the zksync zksync CLI using the command npm install g flag zksync CLI. So let's install this right now. Let's install the the CLI, sorry, npm install g zksync CLI. So because the fact that I've already installed it, it's not going to install again. I already installed mine already. So if you've not installed yours, it's going to install. So now that mine's already installed, I'll just go ahead and create a project called using the zksync CLI. Create project name. Let me use workshop paymaster. So I'll use the contracts, VS, is it has VS version 6. Let me use the ADAT. You can use ADAT or Vepra, but I'm using ADAT. So a private key. So you have to take your private key and impute it there. I already have my own private key. So I'm just going to go and copy mine and use my private key. Just hold on a bit. Let me copy and send this. So you can decide to interact with ZKC using um, Solidity or using Viper. But me myself, I'll be using Solidity for mine. So now I'll paste my private key. I'm using the npm package and now clone into the package. Okay, it's installing. So while it's installing, you can just watch it install. Once again, I'm Kaxi, I'm the Delaware Women DeFi, and I'm also currently a Delaware student at Delaware University. It's gonna take some time for you to get set up, so we just have to just wait for it to get set up. Just a little time. Okay. All right. So it's done installing already. It's all set. So next thing we need to do, we have to open this package now VS Code. So I have to stop sharing this screen and share my VS Code, my code terminal. So let me do this now. So while I do this, I just have to just hold on and go to the let me stop sharing my screen. Stop sharing this, remove, and I'll start sharing my code terminal. So share this now. So currently sharing my VS Code and let me open the template file that I just worked on. This is it. And here we are. Oh, my screen. Okay. Okay, stop sharing. Let me share this again. So it's loading. Okay, now you can see my screen. So if you look at the template file, you would see that it comes with different folders. It has a custom security token. It has the NFT, custom NFT. It has a greater function on Solidity, and it also has deployed scripts and all. So, but for now, we are just going to work with just this greater function and also work with the paymaster function. So let me delete this since it's not needed. It's not needed by me. Move to trash and also delete this as well. Not needed by me. But if it's needed by you, you can work with it. If you want to implement the um, paymaster with your own custom security token, you can just work with that instead. So in here, you can see we have, like I said earlier, I told you we have two kinds of paymaster flow: the approval paymaster flow and the general paymaster flow. So for the approval paymaster flow, we can see that this one has the approval function for you to approve a token. But currently, I'm just going to work on a this solitary function of just a set greet function. A greet function just look like a carry out a transaction on zksync blockchain. So I don't really need the approver paymaster. I need a general paymaster for this. So this is what we are going to use for it. So for that, what we need to do next, we already have this paymaster function. Let me explain this to you. This is made up of the modifier of only boots modifier. This only boots modifier, it takes in the boots format address, meaning that this boots format address is more of like a system program that's only the system that can call this function. This is the modifier for it. And as this function is very, very important, that is what makes the paymaster to work, validate and pay for paymaster transaction. This is what makes the payment start to work. So for this, it takes in the required amount it wants, or the money that we use to pay the gas fee, because definitely you can't carry out a free transaction on the blockchain. Somebody must be paying for it. So this is the work of the paymaster. Paymaster is paying for it. So a token, any token will be sent to this paymaster, and then when it's being sent to this paymaster function, it will then send it to the boot's former address, whereby it's going to hold the token and use that token to pay for any transaction on the blockchain. So this is what it's doing. It's just taking in, making sure that it's only the boot former address that is calling this function. If not, it's going to fail. But if it's one calling the function, it's going to succeed, and there's going to be a success. So this post transaction function is really optional. It's not really that much required, but it's mostly put in here. And there's always a required function, so a withdraw function. A withdraw function is used to withdraw the money, like the money that is being paid into the paymaster smart contract. So in the situation whereby you don't want you don't want to use this function, this paymaster anymore, you want to remove your money from the smart contract, this is the function that is going to enable you to do that. And also there's always a receive function to receive the money. So that's it. So what we need to do right now, we need to deploy two contracts. We need to deploy this greeter function, and we also need to deploy this paymaster function. So to deploy that, we are just going to go to let's just move on to, yeah, let's say this. Okay, this has the greater function already. So let's deploy this greater function. Let's open this. Okay. All right. So come in here. If you're looking at your package.json file, everything has been implemented for you. This is just a random template, making our life so easy. You can see to deploy this deployed script, you just run npm run deploy, npm run deploy, and then it will just automatically deploy. Okay, greeter function not found. So we have to find this. So in here it says, please make sure you have first of all, we have to make sure that we compile this function, compile our code. So we're just going to write npm run compile, making sure that it's compiled. So compiled 41 solidity files, still compiling. So you have to wait for it to compile. Okay. So while it's compiling, I think it's actually nice we have a little background music. I think it's to make it cool. Oh yeah, it has compiled. It has compiled. So now that it has compiled, let's move on to deploying our contract. So let's deploy using this script. npm npm run deploy. So we have deployed our greeter function. Successfully deploy. This is the contract address. So you want to make sure you copy this contract address and paste it somewhere. So for me, I'll prefer to just post it here in my .env example file so that it can be open source and everybody can see it. I can just say greater um contract contract and then this is it. And for this, we're going to have a paymaster contract as well. Paymaster contract. So we're gonna wait for that one. So it has successfully deployed and it's currently on the blockchain on zksync explorer. So next thing we want to do, since we already deployed the greater function, we want to deploy our general paymaster function so that we can use that to hold the ETH and be able to pay for any transaction we want to do on the blockchain. So let's write. I don't think we have a function to deploy our paymaster. Let's write a deploy script. Let's say deploy, sorry, deploy paymaster.cs. So we have that already. What you need to do, we have to start writing the deployed script for our paymaster. So for that, we already have a package that has been installed in our package.json file already. It's let's check it out. This package called um zksync eaters. So that's what I'm going to use to interact with it. Let's go back to our deploy paymaster script. Next thing we need to do, we have to make sure we're importing it. So let's import our wallet. Caps lock. Import the wallet from zksync eaters. We also want to import. There's a custom deployed contract script that I've written for us already. Come in, I will show that to you. Deploy contract. Then also get contract. Get contract. Get wallet, sorry. We're going to get a wallet. And so we're going to get the provider. Get the provider from a utils file that's already been written for us already. Let me just dot slash utils. Yeah. So that's already written for us already. And also we also need to have make sure we have um our etas.js. We still also need to use our etas.js for that for some interactions. So after we're done with this, next thing I want to do, I want to write a function. Let's go for export effort, sync function, sync hello function. So let's delete this. And then, oh, sorry, not together, separate. My bad. So next thing you want to do, we want to make sure that we are calling the contract artifact that's already been compiled already. When we compile the function, we compile that already. So we want to call the API of the contract. So we're going to create a function called a variable, sorry, called contract artifact name, and it's going to be the name of the deployed stuff. We're going to use the general paymaster, so we're going to call it as a general paymaster, the same way it was written there. General paymaster function. Paymaster. So next thing you want to do, the construction argument. So it doesn't really have a construction argument though. We just want to just put it there. Let's check if it has a construction argument. it doesn't really have a construction argument. So I think we need that. Let's remove it. You just have to call the deployed function now. So next thing we want to do in here is to create a variable called contract, and then we use the await function, deploy contract, this contract effect, contract effect name, and yeah, that's it. So we also want to um use a wallet, const wallet, to interact with this. I'm gonna use the get wallets function we already called for my utils, and also use the provider get provider, and then use the await function. Okay, that's wait. Okay, so in here we're going to await wallet that send transaction, to contract to target, and also value it has it's passed. Yeah, and we're going to send because this since we want to deploy this contract, this paymaster contract, definitely there has to be a money inside the paymaster. That's the money that's going to be used to pay for gas, right, on behalf of the user. So let's deploy this contract with um maybe 0.00 worth of its token. So make it 0.001. So this is what to deploy it with now. So let's, yeah, so that's it. Next thing we want to do, we want to make sure that we want to check the balance of the contract after it has been deployed. So we're going to create a variable for that. It's paymaster balance is equals to await provider dot get balance, and also the contract dot target dot convert this to string, so it can be same using the dot string function. And yeah, so we want to console log this so we can see it on our console console.log, and do this for it. Pmaster its balance, because I sent it to it. If it can decide to send any token, had it been we deployed like ARC Trinity token, would have mint token to the paymaster. But no, we're not doing that right now. For this tutorial, we're just going to send some zksync testnet token into it. That's what we're going to do. So calling this variable, put it in here, dot string, convert it to string. Okay. Yep. So this is it. So next thing we want to do, now that we already have this already, we want to make sure that we're able to run this code clear So I'll go into our package or JSON file and include this there. Let's go back to our package or JSON file. Mm, okay, let's copy this one. Deploy paymaster. So come here and run npm run deploy paymaster. Okay, continue deploying paymaster. So this is it. It's going to this is the function here. Currently be deployed already, and the balance right now is one um way. So we'll space it here. I have this already. So let me show you this in the blockchain explorer. zksync blockchain explorer. zksync blockchain explorer. Let me share my screen for you. Let me stop sharing this and share my screen for you. Remove this. And okay. Alright, this is it. So make sure that you're on the testnet and yeah, secular testnet. So let me show you. This is the greater function with the greater code, the greater contract to deploy it. Sorry, this is it. And our paymaster. Let me copy and send you the paymaster. This is the general paymaster. This is you can see that 1.000 all of it was transferred to it. So let's interact with our paymaster now. So now it's time for us to interact. We have deployed the greater function. We have um we have deployed our paymaster. Now it's time to interact with the paymaster. All right, share my screen back. So for what we need to do, we have to create a script called paymaster. So maybe interact the tx to interact with our paymaster. That's what we need to do. So let's create our script. Come here. Let me use this already. Okay. I think it has a lot of things I need. Just have to okay, let's use this template. We'll work with this template. What we need to install Let's import our utils. Import the utils from zksync guitars. Zksync guitars. Then also import pmaster. Pmaster from dot slash deploy paymaster back. No, from the paymaster. Yeah. Okay. Then let's also import. Okay. Let's use there's something called get paymaster params. Import get paymaster params. From zksync it has um slash build slash paymaster which is yeah. So for this we're just going to fix in the let's copy this, paste this, change this to pmaster address. Pmaster address. So let's copy the addresses we already have. This is for the greater function. Copy this one and paste it in here. Then also copy this one and paste it in here. Where's it? In here. Yeah. So want to edit this code and just make sure that we do this or add the paymaster address. So if it doesn't have the paymaster address or it's show an error. So now we're going to log this one. Okay. And what we need to do, we have to write a function to get make sure that we're getting the greater function. So let's come here first. Do this. Cons cons contract is equals to new iteras dot contract. I think we already have that already. Okay, this is it. We already have this already. Let's work with this. It's part of the template. Control that tracks, API, contract part API, and go to like we already have this already. So we don't have the provider. Let's use the provider here. Const um provider is equals to get provider. Okay, the provider was imported from it's not here. I didn't import it. So let's import it. Oh, let's just come here and copy and paste it. This one we use from here. Copy it and come here. Oh, sorry, it was just I didn't just put it here. Then come here, remove this. Then also remove this one. It's not needed. Okay, so lab is already, so no more errors. So now the provider is there. You have to get the balance before interaction, then interact with it. So in here, um, let's put it here. Let's balance before before transaction is equals to await provider get balance. Provider does get balance, then get wallet, then got address. Yeah, it's okay. This is going to use for the get the balance for transaction. Let's console log this one. Okay. Yeah. So the wallet before the interaction. It has, oh sorry. We're just gonna use it as for this one. It has, okay. It has format balance before transaction and all. So that's it. So let's write a greater a costume, sorry, yeah, let's write a costume greeting message. Let's just write const greet message equals to hello, this is Coxie and Peter. Hello, this is Coxie and Peter. We are Devers. We are Devers. So let's interact the paymaster param that we imported from here. Paymaster param from here. So let's remove this. We don't need this one. Don't need it. So remove it. So let's interact with const paymaster param param param. Sorry, it's equals to get paymaster params and also passing the paymaster address, deployed address, and this is going to be the type of the paymaster. This is general paymaster. Type is general and inner input. Yeah, input goes to new int it's array. So it's gonna be function. Alright. So now let's call the transaction. So this is what you have this. So contracts, sorry, contract dot set greeting. Hello. So set greeting. This we're going to sort of using this hello people. We already have this. Let's put get. We already have this. Let's just put get message. Sorry, greet message, and then pass in the paymaster to pay the function, pay the gas first. So it's going to be custom data like this. Then this paymaster param that what is set in here. So that's just it. So after we're done with this, we just want to console log the transaction. This is transaction dot hash, and after that, we're going to wait for the transaction to work, and then we want to check the balance of our account to be sure that yeah, we didn't pay for the gas, but the paymaster paid for the gas. So let's check for this. Let's balance After transaction, after transaction equals to await provider dot get balance to get the balance of our wallet. So get wallet is gonna be a function dot address. So that's it. So we're done with that. We want to console log this. We want to console log this. Console log. So yeah, this can check the message we sent. Then I want to console log the balance after this is it. Balance after. Let's put this. Go to X. Put it here before checking the message. So it's going to be it has um it has a format balance after. So that's it. So once you want to do now, want to sorry, we want to check this. You see here is balance here is so I want to run this code. So go back to our package.json file and run the code with npm run interact. This one to that's what we run the script. So it's running. Okay, run the script. Balance before my balance before. Okay, there's an error. Paymaster validation transfer fee put to the paymaster might not be enough. Oh, there's not enough it to run this on the paymaster. Could not cause error. Fail to validate the transaction. Reason validation error. Paymaster validation error. Fail to transfer transaction fee to the bootmaster. Paymaster balance may not be enough. So let's run the paymaster script again. Yeah, let's run the paymaster script again. Let's deploy init paymaster with um coming deploy paymaster 0.001. Okay, let's this time deploy it with 0.01. Let's deploy this paymaster again. Sorry about that. We're going to change the um we're going to change the paymaster address. This is the address, right? Let's copy this. Come here, change it from here. Paymaster address. Save. Then come back in here, change the address. Paymaster address. Then run it again. Let's pray it works. Okay. Balance before. My balance before. Oops. It's an issue. Payment balance may not be enough. So let's check our code again. Check it again. Mm, guessing this is too much. Interact. I don't have enough it. I didn't send enough it. Oh yeah, the reason was because the message I'm sending is like a whole lot. It's going to take a whole lot of gas, and the amount of tokens I sent to my paymaster was very, very little to cover the gas fee. So my paymaster didn't have enough tokens in its bootloader to cover the gas fee. So you can see here that when I just shorten the message, it worked. So let's copy this transaction ID and check it on the blockchain. But here you can see that I didn't pay for gas fee. My wallet balance was 0.018 and now it's still 0.018. And see, I was able to interact with the set greeters function for free. Like I didn't need to pay. That's what's so amazing about Paymaster. And this is the message I sent to the blockchain. So let's check it again. Let's check the blockchain for the message. I just copied the transaction ID. Let me share my screen. Okay, hold on. All right, so let me share this. So this is the beautiful thing about Paymaster. Like it helps you to pay for anything, but always remember that if you are using, oh my god, I can't find the, okay, this is, if you are using a token, if you are trying to send tokens, make sure you use the approver paymaster for that. But if you are just interacting in normal tap without sending tokens, make sure you are using the general paymaster. So this is the message I sent to the blockchain. This is the paymaster details. You can see that it was gas was paid by my paymaster. So this it's, I hope you understand. So if there's any question, do wait to ask your question, and you can drop your question in the comment section, and I will make sure I attach the docs to zksync and also attach the link to my repo. So thank you so much for being here all throughout my workshop with my team. It was an amazing workshop. So bye.